to work on 106 through 109, where we are talking about just basic differentiation rules. So if we look at 106, problem number 106, you'll see that our basic differentiation rules say if we have a standalone constant, that derivative will be 0. And it says we can differentiate term by term, and that the power rule, we bring down the exponent and subtract 1 from the exponent, provided that our x variable is in the numerator. So if you look at problems 106 through 109, all of those you can use using these basic derivative rules. So for the first one here, what we will do is we will use the power rule for the x to the 7th. So we will bring down the 7 by the power rule. And remember that when we bring this down, we are now taking the derivative. So it's no longer f when we bring it down. Now it's f prime is equal to 7x, and then by the power rule, we subtract 1 from the exponent. So 7x to the 6th. Then this plus 10 is a standalone constant, so that becomes plus 0. So it's standing all by its little lonesome there, so it becomes plus 0 when we take the derivative, and so our derivative is 7x to the 6th. So similarly, let's look at question number 107. So here we're going to use the power rule because we have x to a power. This 5 is not going to go to 0 because this 5 is with something. It's with this x. So the 5 is going to tag along. Then we are going to take for our x to the 3rd, we will use our power rule. So we will bring down the exponent and then subtract 1 from the exponent. So 3 minus 1 will give us 2. All right, so of course we can simplify this. The 5 times 3 gives us 15, x to the 2nd power as the first term for our derivative. Now, the second term we see is x to the 1st power. And that's a very important thing to notice, that it's to the 1st power, because that tells us that we have a linear term. And anytime we have a linear term, we discussed that our derivative will simply be the coefficient. So the coefficient in front of this negative x is understood to be -1, so the derivative is the coefficient when we have a linear term, so we'll have -1. And again, -1 doesn't simplify, so I'll just rewrite that below. Now, the plus 1 is a standalone constant, so that plus 1, when I take the derivative, will go to 0. So standalone all by its lonesome will go to 0, and so we will have that our derivative is 15x squared minus 1. All right, so let's look at the next one, question 108 here. So again, the 4 is with something, it's with this x squared, so the 4 will tag along when we take the derivative. The derivative of x squared, we use our power rule, so we bring down the 2x and then subtract 1 to get x to the 1st. So that will become just 8x when we simplify. Now, the -7x, we notice that that's x to the 1st power, so that tells us that it's a linear term. And when we have a linear term, we simply use the coefficient. So this will be -7, so we will get that our derivative is 8x minus 7. So finally, question 109 here, you can also use the power rule and differentiate term by term here. So you have that the 8, because it is with something, will carry along. The x to the 4th, we use the power rule, so bring down the 4, subtract 1, plus the 9 is with something, it's with the x, so it tags along. The x squared becomes 2x to the 1st power because we're subtracting 1. And then the -1 is a standalone constant all by its lonesome, so that will go to 0. So then finally you simplify by multiplying the 8 times the 4 to get 32x to the 3rd plus 18x. And that is our final answer. Now, the one thing to notice here is that this is not the same thing as f of x. When you do this whole bring down the exponent, subtract 1, you are using your derivative rules, and so this is f prime. So our f prime of x is equal to 32x cubed plus 18x.